Hello students, today in the fifth video of laws of motion students, we are going to derive the formula for laws of conservation of momentum students. So here let us start with laws of conservation of momentum. In the law of conservation of momentum, first we'll assume some things that I'll tell you what to assume. Here suppose two objects are there, A and B. Suppose two objects A and B, they collide. That means they will have collision. In other words, I'll say that one will hit the other. Now here let us assume the object A is having mass m1 and the object B is having mass m2, students, mass m2. In the same way, initial velocity, students, when initially the object A is traveling, suppose initial velocity of object A is u1 and the initial velocity of the object 2 is B is u2, students, of object B is u2. After the collision, once they will collide with each other, there will be collision or they will hit each other. After that, suppose the final velocity of object A is v1 and the final velocity of the object B is v2, students. Now here this is our assumption, therefore we can say initial momentum. Students, we know momentum is nothing but mass into velocity. Mass into velocity is called momentum. Students, we have done this in our last videos. So here you will just remember momentum is nothing but mass into velocity. So here when we'll talk about initial momentum, mass into initial velocity. So m1 u1 will be the initial momentum of object A and m2 u2 will be the initial momentum of object B. Here mass into initial velocity, initial momentum of A, mass into initial velocity, initial momentum of B, student. So here we got initial momentum of A and B. We got initial momentum of A and B. Initial momentum of A is m1 u1, initial momentum of B is m2 u2, students, m2 u2. Now let's continue. When we'll talk about final momentum, again we know the formula is same, mass into velocity, but we'll take final velocity this time, students. So here for final momentum, the formula will be mass into final velocity. So we'll get final momentum for object A m1 v1, mass into final velocity, we'll get the final momentum for the object B, students, m2 v2. Let's continue, students, let's continue. So here you will assume and you will do like this, students. This is the shortest and more convenient way I have given to you how to write what to assume. Otherwise when you will sit to write theory, it is seen that many times you miss some points and some mistakes are done. It may be a grammatical mistake or something. So better you write like this, students. Let's continue. If f1 is the force acting on A and f2 is the force acting on B, suppose f1 and f2 are the force acting on A and B. Now here A and B, when they collide, here the force of action will be equal to force of reaction, because we have already studied, students, according to Newton's third law of motion, force of action is always equal to force of reaction, only direction is opposite. So here to indicate that direction is opposite, I have written minus sign, students, and I have written f1 f2 and f1 are equal. F2 and f1 are equal, just sign is different. So here I have substituted one minus sign over here, students, minus sign over here. Why? Because the direction is opposite. So here by using third law of Newton, according to third law of Newton, we are having only one formula, f2 is equal to minus f1, students. What I'll do, students, I'll put the value of f is equal to, students, we have already studied, f is equal to mass into acceleration, students. Ma that is mass into acceleration. So when we'll talk about f1, students, it will become m1 a1. When we'll talk about f2, it will become f2 is equal to m2 a2. So I have substituted values, students. Instead of f2 I have written m2 a2, and instead of f1 I have written m1 a1, students. You can see here, students, instead of f2 I have written m2 a2, and instead of f1 I have written m1 a1. Why? Because F is equal to ma. We have already studied in the um, second law of motion, students, given by Newton. Now here, students, so we have reached till second equation. Now we are having m2 a2 is equal to minus m1 a1. Minus sign is as it is copied from up, students. It is copied as it is from up. Now students, when you will see acceleration a, acceleration is having formula a is equal to final velocity minus initial velocity upon t, students, upon t. Acceleration is equal to final velocity minus initial velocity upon t, students. So what I'll do here, students, I'll just put a1 is equal to v1 minus u1 upon t. Time is same, students. Time interval is same for both the objects a1 and a2. Object a and b. Now here, acceleration, we know the acceleration is change in velocity per unit time, students. So here acceleration is equal to v minus u upon t. I have used the formula here, v minus u upon t. When we'll use a1, it will become v1 minus u1 upon t. And if it is 2, a2, a2 will become equal to, a2 is equal to v2 minus u2 upon t. So here I'll substitute the value, students. I'll substitute the value. A2 is equal to v2 minus u2 upon t. See here, students, instead of a2 I have substituted the value v2 minus u2 upon t. In the same way, instead of a1, students, I have substituted the value v1 minus u1 upon t. So here I have utilized the formula acceleration is equal to v minus u upon t, and I got the result, students. When you will see, students, both the side we are having t, we'll just cancel these two t's. 2t are there on both the side. We'll just cancel this t from left side and right side. When they are cancelled, the equation will become like this, students. Here m2, I'll just repeat equation. What is the equation, students? Now here we'll get the equation, this equation. Here m2 as it is. Here this second bracket, when you will see v2 minus u2, it will remain as it is. m1 as it is, students. This minus sign is as it is. v1 minus u1 will as it is. Only t is cancelled, students. Everything is same, students. Only t is cancelled. These two t's are cancelled. Everything is same. So here we have reached till this equation, students. Now what we will do, we'll just open the bracket. When we'll multiply m2 with v2, we'll get m2 v2. When we'll multiply m2 with u2, we'll get m2 u2. When we'll multiply minus m1 with v1, we'll get minus m1 v1. When we'll multiply minus m1 with minus u1, here, students, minus and minus will cancel each other and we'll get plus here. Students, you will take care. Here it should be plus, students. Now here minus m1 minus u1, it will become plus m1 u1, students. So here we got the step. Now what we'll do, students, we'll just change the side of the negative terms. We'll change the side of the negative term. Here m1 v1 minus m1 v1 will go that side, and minus m2 u2 will come this side. So here in this way, when you will change the side, they will become positive, students. Here when you will see minus m1 v1, it is negative, but when you will change the side here on the left hand side, when it will become plus m1 v1. In the same way, here m2 u2 is negative. When you will change the side and it will come on right hand side, it will become positive, students. Now here you can see the final momentum, that means final momentum of object 2b and final momentum of object a. So here total final momentum we are having. I'll repeat again, students. Here m2 v2 is there, that means final momentum of final momentum of second object b. Here the final momentum of object a. So here it is total final momentum is equal to initial momentum of a plus initial momentum of b, total initial momentum. So here we got total final momentum is equal to total initial momentum. That means there is no change in momentum, students. Initial momentum and final momentum total, when we are talking about total momentum, total initial and final momentum are same, and this is nothing but called as law of conservation of momentum, students. Law of conservation of momentum. Let's continue with some sums, students. We'll start solving some sums here. We have already studied three equations of motion, students. We have already studied three equations of motion, and these equation of motion are v is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as, students. On the basis of these three equations, we have to solve some sums given over here in this table, students. When you will see in this table, students, here first question, here first question, what we have here, first row, when you will see, u is given 2, students. U is given 2, a is given 4, t is given 3. What we have to find is v. We have to find v, students. We have to find v. Even formula is given, students. Even formula is given over here. We have to use the same formula. V is equal to u plus at. So I'll write the same formula here, students. You just see. I'll write v is equal to u plus at, students. A t. I have written the same formula which is given over here. V is equal to u plus at, students. Now what I'll do, students, I'll just substitute the value. V is equal to u value is given here 2, students. U value is given here 2, so I'll write 2. Now plus a value is given 4, so I'll put the value 4 here, into t value is given 3 here, students, so I'll put the value 3. So here in this way, when I'll put the value, I'll get 2 plus 4 3s are 12, students. 4 3s are 12, and I'll get final answer 12 plus 2 14. Here unit is also given, students. No need to search for unit even. We'll get unit meter per second. But you will remember, students, so in exam it will not be there. So in this way you will solve the sum. Here we have solved the first sum, and we'll get the answer 14. We can fill here 14, students. We can fill here 14. So we got answer for first row, students. In the same way we can continue with the second. I'll show you, students. I'll show you, just a second. I'll just rub this all, and then I'll do for second one. So just remember, students, second one also we are having the same formula. V is equal to u plus at. V is equal to u plus at. Same formula I have written for second one also. I'll just substitute the values which are given to us. Now here when you will see, u value is not given. U value we have to find. So here instead of u, I'll not substitute anything. I'll keep it u only. Plus a value is given over here, students. It is 5, so I'll write 5. When we'll see t value is given, t value is 2, so I'll put here 2, students. I'll put here 2, and v value is also given over here, students. It is 20, so here instead of v, I'll put 20 here. Even I'll put the value 20 over here, students. I'll put 20. Just a second, students. I'll put the value 20 over here. So when I'll put the value 20, now what I'll do, I'll solve it, students. 20 is equal to u. Just a second, students. U plus, just a second, students. This u is not looking good. I'll write it properly. Oh god, yes. Now u plus 5 2s are 10, students. 5 2s are 10. I'll just change the side of 10. Here it is 10 is addition, students. 10 is addition. When I'll change the side, it will become subtraction. Here 20 minus 10 will get is equal to u, students. Is equal to u. Now when you will subtract 20 minus 10, will get 10. We'll get 10. So here u is equal to 10, students. Here we are getting u is equal to 10. Now here u is having unit meter per second. Velocity is measured in meter per second. So we will write meter per second, students. Meter per second. So here we got the answer for the second. In second it will come 10, students. In second it will get 10. So we can fill here 10, students. So in this way we can solve the second one also. Students, let's see the other example. When we'll see the next one, I hope you must have understood this. Let's continue with the next. When you will see the next sum, students, when you will see the next sum, In next sum we are having u, we are having a, we are having t, or and we have to find is s. What we have to find is s, students. We have to find s. What we'll do here, students, we'll just write the formula here, as we did in first one. In the same way we'll do here in the second one. I'll just write the formula here. Formula is s. S is equal to ut plus half at. Just a second, students. Ut plus half at square, half at square here, students. Just a second, students. Half at square, at square. So I have written half at square, ut plus half at square. Now I'll just substitute all the values whatever given over here. Now s is equal to u value is given to us and it is 5, so I'll write 5 over here, students. 5 instead of into instead of t we are having t value 3, so I'll put 3 plus half just a second, students. 2 is not proper, yeah, 2 just a second. I'll write 2 into a is again a is having 12. I'll write put value 12. T square, t is 3, so square is there. I'll write 2 times, students. I'll write 2 times 3 into 3. T square is there. Now we'll solve the sum, students. When you will see here, 2 ones are 2, 2 6 are 12. We'll cancel this 2. Now here when you will multiply 5 3s are will get 15, will get 15. 5 3s are 15. Now students, 3 3s are 9, 9 6 are 54, 9 6 are 54. I'll write 54 over here, students. When you will add 54, and 15, you will get 69, students. You will get 69. So here answer is 69. Now what is the unit? It is meters, so here I'll write meters, students. In this way you can solve the sum, students. In this way you can solve the sum. Let's see the next sum. How to solve the next sum, students. So here I'll teach you how to solve the next sum also. Just a second, students. I'll just rub this and then we'll continue with the next sum. I'll just rub this and then we'll continue with the next sum, students. I'll just rub and remove this so that we'll able to continue with the next sum, students. Just a second, students. So here when you will see the second sum, in second sum we are having u value, so I'll put the u value 7. We are having t value, I'll put the t value 4. Whatever value is there we'll just substitute. Half as it is, a value is there, no, a value is not there. I'll keep it as it is. T square, t value is there, yes, t value is 4. I'll write 4 2 times because it is square. And even we are having s value is 92, so I'll write 92 over here. So here we got 92. Here 92 is equal to, I'll write 92 is equal to, we are having 92 is equal to, students, 7 4s are 28, 7 4s are 28, students. So I'll write 28 over here. 28 I'll write over here, students. Just a second, 8 is not proper, I'll make it proper. 8 28 plus, when you will divide, 2 ones are 2, 2 twos are 4, students. 2 twos are 4, so here we'll get 4 twos are 8a, 4 twos are 8a. So here I'll write 8a, students. I'll write 8a. So in this way you will continue, students. In this way you will continue. Now just change the side of this 28. When you will change the side of this 28, it will become 92. 92 minus 28 is equal to 8a, students, is equal to 8a. Now you will just subtract 92 minus 28. 92 minus 28. When you will subtract, students, I'll just subtract, students, just a second. It will be 64, students. It will be 64 is equal to 8a. 8a. Now here, students, I'll just divide both the side by 8 because 8 is there that side, students. I'll divide both the side by 8. So 8 8 cancel, 8 8s are 64. 8 8s are 64. So here we got a is equal to 8, students. We'll get a is equal to 8. Now what is the unit of a? Unit of a over here is meter per second square. So here we'll write meter per second square, students. meter per second square. Here place is not there, so I'm not writing, but you will make sure that you will write, students. You will write 8 meter per second square. Students, for today I'll stop my video over here only. In the next video we'll continue from the third table, and we'll solve few sums which are there in exercise, students. Thank you very much, students. I hope you must have learned a lot from this video, and you will subscribe my channel so that next video when I'll upload, it will reach to you directly, students. It will reach to you directly. Thank you, students. Thank you for the day.